Okay, so you should have covered 6.1 and 6.2. Now we will be doing 6.3, what are chemical equations and how do we balance them. Okay, so before we do the other chapters, you really need to know how to balance chemical equations, which I found out is quite a area of weakness for a lot of you. So the learning outcomes is to interpret chemical equations with state symbols, construct chemical and ionic equations with state symbols. And by now, whenever they say state symbols, you should know that there are 4 different types. We have solid, okay, also known as S, liquid, L, gas, G, and also aqueous, AQ. Alright? So these are word equations. The chemical names of reactants and products are used. Okay, so reactants are placed on the left hand side of the equation while products are the right hand side of the equation. So if you're not so sure what are reactants, reactants are basically substances that you put together to react together to form a product, which is the right hand side. Okay, so in this case, your reactants are sodium and chlorine, and your product is sodium chloride. Okay, so this is a word equation. Everybody should know how to do or write down a word equation. Okay, but the more difficult thing is to convert it into a chemical equation. Okay, so in this case, sodium, if you look at your periodic table, is Na. Okay, and sodium usually exists as a solid because it's a metal. Plus chlorine. Chlorine is a gas. And remember, chlorine is in group 17, so it exists as a molecule. So we write it as Cl2, gas, arrow, sodium chloride, okay, is a product, which is your common salt. Okay, and sodium chloride is usually in a solid form in this case. Okay, so now we need to balance. Okay, but for now, just need to know this. Okay, but if I were to balance it, later I'll teach you how to balance it. Okay, you just have to make sure that the number of atoms or the number of the number of atoms on the left hand side equal to the number of atoms on the right hand side. Okay. So, balanced chemical equations represents the ratio and the states of the reactants and products. Okay, so just now the states of reactants and products is referring to the state symbols. Okay, so everybody need to know this. Okay, and the ratio is represented by this numbers here. Okay, so the ratio of sodium to chlorine gas is 1. Okay, and the ratio of all of this to sodium chloride is like this. So 1 is to 2. How do you know whether chlorine gas is 1? Okay, usually we don't write down the 1 here, but there is an invisible 1 here. Okay, an invisible 1, we don't really represent the 1, so we can just remove it. You can just write Cl2 instead of 1 Cl2. Okay, all right, so this is the ratio. Okay, so take note, every atom on the left hand side of the arrow must appear on the right hand side of the arrow. So just to repeat it again, sodium plus chlorine gas gives you sodium chloride. Okay, I'm going to teach you a new method, which is, previously I taught you using this one, right, and then left hand side, right hand side, right? Okay, we can do this first. Okay, so let's take a look at the left hand side. You have 1 sodium atom. On the right hand side, I have 1 sodium atom. On the left hand side, I have 2 chlorine atoms. On the right hand side, I have 1 chlorine atom. Alright, so which one is not balanced? Okay, is your chlorine. So I need to times 2 here, right? But if I were to times 2 here, correct, I need to times 2 on sodium as well. But now my chlorine is balanced, but my sodium atom is not balanced. So what do I need to do? I need to times 2 here to make sure that all the sodium atoms on the left hand side equals to the right hand side. Okay, so now I can just simplify it. I can just write down 2 sodium, chlorine remains the same, and then you have 2 NaCl. And some of you get confused at this point what this 2 means. This 2 means it multiplies here and here. Okay, which means it represents 2 sodium atoms plus 2 chlorine atoms. Okay, so you just write the 2 at the front. Alright, so the 2 at the front includes both Na and Cl. Okay, there's also another method. It's called metal. Okay, let me write down in another color. Metal CHO. So firstly, basically what we do is to balance out the metals first, and then we balance out the carbon, then we balance out the hydrogen, and then finally we balance out the oxygen. Okay, so if I were to redo it, okay, let's try. NaCl2, NaCl. So what do we need to do again? We balance out the metals first. Okay, so the metals are balanced here. Okay, next we balance out the carbon. Alright, there's no carbon, there's no hydrogen, there's no oxygen. Okay, so finally we have to balance out the chlorine. Okay, so maybe we should add one more here. Others. Okay. Alright, so finally we are at others. Where others again we balance out the chlorine. So we need to balance out this one. So how do we balance out this one? We just have to add a 2 at the front. Okay. So once we balance out the 2 at the front, we need to balance out 2 here. And now it is balanced. Okay? Yeah, so that is the metal CHO others method. Okay, usually it's easier to understand the left hand side, right hand side method compared to the metal CHO method. Okay, it's easy to understand that. But there are certain cases where you cannot use the left hand side, right hand side because the chemical equations are too complicated. Let's try this one. Level 1, sodium, hydrochloric acid, sodium chloride, hydrogen gas. You can pause the video now, okay, to try the questions before you look at the answer. Okay, so we can do the metal CHO method here. Okay, so first balance out the metal. So the metal here is sodium. On the left hand side you have one sodium atom, on the right hand side you have another sodium atom. Okay, so it's balanced. Carbon, no carbon, let's skip that. Hydrogen, let's balance hydrogen next. On the left hand side I have one hydrogen, on the right hand side I have two hydrogen. So what do I need to do? I need to put a 2 here, correct? So now my hydrogen is balanced on the left hand side and the right hand side. Both sides have 2 hydrogen atoms. And then finally there is oxygen. No oxygen. So let's skip that one. And finally let's balance out the others. So what's next is chlorine. So now you have on the left hand side you have 2 chlorine. Remember there is multiplication like this. Okay. Alright, so there's 2 chlorine atoms on the left hand side. On the right hand side I have 1 chlorine atom. So what do I need to do? I need to add a 2 here. So now my hydrogen is balanced, my chlorine is balanced, but what is not balanced? My sodium, my metal is not balanced. Okay, so now I have 2 sodium atom on the right hand side. What is on the left hand side? Is 2. So I need to put 2 at the front. Now you can double check. You have 2 sodium atoms on the left hand side, 2 sodium atoms on the right hand side. Tick, tick. 2 hydrogen on the left, 2 hydrogen on the right. Tick, tick. And then finally 2 chlorine on the left, 2 chlorine on the right. Is it balanced? Yes, it is balanced. Okay, let's continue. You have magnesium carbonate MgCO3 plus HNO3 arrow Mg bracket NO3 2 plus carbon dioxide plus water. Okay, now it's a bit more complicated, so again let's take it step by step. Alright, so again let's do the metal CHO others method first. Metal, what is the metal here? It is your magnesium. Magnesium on the left hand side I have 1, right hand side I have 1, balanced. Next let's take a look at carbon. Okay, so left hand side I have 1 carbon, right hand side I have 1 carbon. Okay, so that's balanced. Okay, let's take a look at hydrogen. Left hand side I have 1, right hand side I have 2. Okay, in water, you see in water there's 2. So what do I need to do now? I just need to add a 2 at the front here. Okay, so 2 hydrogen, 2 hydrogen. Okay, and then finally let's take a look at oxygen. I have 6 oxygen on the left hand side. I have 6, 7, 8, 9. 9, 6, 7, 8, 9. I have 9 oxygen on the right hand. Left hand side I have 3, 6. Okay, because remember this 2 is multiplication to all. Okay, so now I have 6 oxygen on the nitric acid, and then 3 oxygen in magnesium carbonate, so total 9. Right hand side I have again this one, this 2, this small 2 at the back here is multiplied to both because it's a bracket, same like in mathematics. Okay, so it's 2 nitrogen and then 6 oxygen plus the 2 oxygen atoms in carbon dioxide, so 6, 7, 8, and then 1 oxygen, 9 in water, so 9 total. So both oxygens are balanced. Okay, all right. So do we have others? We have nitrogen. Okay, so we have 2 nitrogen on the left hand side, 2 nitrogen on the right hand side. Okay, so let's double check again. 1 magnesium on the left, 1 magnesium on the right. Okay, so it's tick, tick. 1 carbon on the left, 1 carbon on the right. Oxygen, you have 9 oxygen. So 1, tick, 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 and tick, and tick. Okay, and then finally you check your hydrogen. Second last one, you check your hydrogen. You have 2 here, 2 here, and finally nitrogen, you have 2 here, 2 here. Okay, so all balanced. Okay, so now this is your balance equation using the metal CHO others method. Okay, and then finally let's go through this one. This one is a bit more complicated. Oops. Okay, Okay, so again, using the metal CHO others method, first let's check if there's any metal. Yes, there is. It's sodium. So you have one sodium left, one sodium right. So that's balanced. Next, carbon. Is there any carbon? No carbon. Let's skip that. Hydrogen. Okay, so there's 5 hydrogen on the left. And you have 5 hydrogen on the right. So that's balanced. Okay, next. Oxygen. 1 oxygen on the left, 1 oxygen on the right. So that's balanced. Actually, this is a balanced equation already. And others, which is your nitrogen, 1 nitrogen, yeah, 1 nitrogen. Okay, that's fine. That's quite easy. Okay, so finally we have to talk about ionic equations. Okay, so ionic equations show the ions that take part in the reaction. They usually involve at least one aqueous reactant that is usually an ionic compound. And it can be constructed from a balanced chemical equation. Okay, I've already given you the worksheet before. Go back to your file, you take a look at your notes. Okay, but basically ionic equations require you to understand what is aqueous and what is other states. So only the aqueous states, right, you split them into its different constituents. Okay, take note, only the aqueous ones. So in this case, only sodium hydroxide, hydrochloric acid and sodium chloride, you will separate them, or rather break them up into its constituent ions. And then take note, you need to cancel out the ions that appear on both sides. Okay, what are these ions called that appear on both sides? They are called the spectator ions. Okay, means they are just sitting at the sidelines, they don't do anything, they're just watching the whole reaction takes place. Okay, and the ones that doesn't appear on both sides, those are the ones that are actually carrying out the reaction. So in this case, it is your hydroxide ion and also your hydrogen ion. They react together to form water, okay, which is simplified as this here. Okay, which is OH minus plus H plus gives you water. Okay, all of these, okay, take note, all of these are spectator ions. Spectator ions. Okay, they're just watching. Alright, okay,